Hello, good evening everyone. Welcome to BYJU'S exam prep. So I hope that the video and audio is absolutely fine. So guys, quickly share the session with all of your friends. Here we are going to discuss the digital communication questions from the subject communication system for the previous year. That is your IISc Bangalore. IISc Bangalore questions we are going to discuss. Okay. IISc Bangalore questions we are going to discuss. So I have shared the session with your friends. Let me share with more groups. Maybe the students will take interest and they will join. Because the digital communication is the most important part of the communication, and it is important for all of you to attend the session live. If you have any doubt, then you can comment in the comment section that how to prepare and what to prepare. Then I will take those questions as well. So before starting the session, let me introduce myself. So this is Saket Verma, and I'm having more than 13-year experience, and I have done MTech from IIT Guwahati as well. And my area of expertise are electromagnetic theory, communication system, advanced communication system, signals and system, etc. So these are my area of interest, and my Telegram group you can join. That is by the name Study with Saket Verma or Electronic by Saket. So you can search in the Telegram Electronics by Saket, then you will get the uh, Telegram group and where you can join, and these PDFs I will be sharing in those groups. So UPSC ESE 2023 mains results are out, and if you are preparing for interview, then you can attend our free mock panel interview. And for this, you have to share your result in the link given in the description. And guys, this was the first question that we discussed yesterday. All these questions we discussed yesterday. Okay, and we will take from the next onwards, like from here. Yes. So up to this point we have discussed. Now starting from this question. Starting from this question. So I'm giving you the time to solve this problem if you don't know about the concept of the. So you have 2 minutes to solve this problem. 1.5 minutes. Four messages band limited to WW, 2W, and 3W respectively are to be multiplexed using the time division multiplexing. The minimum bandwidth required for the transmission of this. Minimum bandwidth required for the transmission of this TDM. You have 30 seconds more. Answer this question quickly. Okay, now there are four messages and each value limited to W, W, 2W and 3W, and we have to do the time division multiplexing using the minimum bandwidth required it is asking. So the bandwidth requirement is generally we calculate by bandwidth requirement is we can calculate it by the bandwidth is W, so the overall bandwidth will become, that is your the sampling frequency of all the signal and divide by 2. So it is W plus the bandwidth of this W and 2W and 3W. So overall 7W are required bandwidth. Minimum bandwidth required would be 7W. If you are multiplexing with the time division multiplex signal, then your minimum bandwidth would be the addition of all the bandwidth required or for all the four messages. So the right answer would be option D. Now answer this one. Last 30 seconds. A speech signal band limited to 4 kHz and peak voltage varying between +5 and -5 is sampled at Nyquist rate. Each sampled is quantized and represented by 8 bits. Then if the bit 0 and 1 are transmitted using the bipolar pulses, the minimum bandwidth required for distortion-free transmission. So here, as you can see that the signal is band limited to 4 kilohertz. So the sampling frequency will be twice of FM. So it would be 8 kilohertz, right? And we want to calculate the bandwidth. So bandwidth is generally RB by 2 for the sync pulse. Okay, that is a raised cosine pulse or sync pulse. But here it is asking for the polar. So polar will have the bandwidth RB, that is for bipolar. Okay, so for bipolar it is RB. RB is N into Fs. So how many bits you are using? 8 bit you are using. What is the sampling frequency? 8 is the sampling frequency. So answer would be 64 kilohertz. Okay, actually there is the ambiguity between these, that if we consider the distortion free transmission, so for distortion free transmission we generally take the sync pulse, and if we take the sync pulse, then our bandwidth should be RB by 2, so it is 64 upon 2, so it is 32 kilohertz. And if we consider these bipolar pulses, and if we consider these bipolar pulses, it is not necessary, uh, because it is saying also the distortion free. So usually we always follow the distortion free condition. So the distortion free condition should be satisfied, and that is more important for the communication to make happen effectively. So our answer would be 32 kilohertz, but there may be the confusion of this 64 kilohertz because of the bipolar. But why we are not taking the bipolar? Because this sync pulse can also be one, and means have the positive value and the negative value with the bipolar polarity. That is that sync can also have the two polarity, positive pulses and negative pulses. But the distortion free condition cannot be occurred in case of bipolar transmission. It is mainly for the sync pulse it is possible. So 32 kilohertz would be the right and appropriate answer for this question. Now answer this one. The same question is there, but now it is saying that the signal is uniformly distributed. Signal is uniformly distributed now. Signal is uniformly distributed. Come on, answer the question quickly. Yes. Now the what will be the answer? Uniformly distributed between the peak value of the message signal. What is the peak value? So if it is uniformly distributed, the peak values are minus 5 to 5. So it is uniformly distributed between minus 5 to 5. So it is minus 5 to 5. It is distributed. So the height will be 1 upon 10. So how will you calculate the signal power? The signal power would be the signal power would be this is nothing but a mean square value, and mean square value is b square plus ab plus a square divided by 3. The b is 5, then minus 5 into 5, this is ab, and a square is minus 5 whole square divided by 3. So it is cancelled, and hence the signal power we will get as 25 upon 3. What about the noise power? The noise power is NQ is nothing but the delta square by 12. So the highest value minus lowest value divided by L will be the step size whole square and divided by 12. Highest value is 5, the lowest value is minus 5 whole square divided by 12 into L, that is 2 to the power 8. So this is 100 upon 12 into 2 to the power 8. Okay, 5 and minus 5. So it is 10, 10, 100 is square and this one. So now when you will solve it, you will get 3 and 25. Hence, when you calculate the signal power to the noise power, here, if I calculate the signal power to the noise power, I will be getting the 25 upon 3 into, sorry, 25 upon 3 is the signal power, and then 25 upon 3 into 2 to the power 8. So it all will get cancelled and we will get 2 to the power 8. And 2 to the power 8 is approximately 48 dB. 2 to the power 8 is, yes, 10 log 2 to the power 8 you can calculate. So I think it is approximately 48 dB. Let's check. Let's check with the calculator. 10 log 2 to the power 8. Yeah. So L square was there. Na? So L square was there. So it is 2 to the power 16. So it is 2 to the power 16 and 2 to the power 16 is 48 dB. We have one mistake here. This is 2 to the power 16 and 2 to the power 16 is equal to what? 48 dB. Okay, so there was a mistake that it was a L square, and L square means 2 to the power 2n. So we have to put the 2 to the power 2n. So that means 2 to the power 16. So finally we will get 2 to the power 16, that is 48. Okay, so answer is 48. Now the third part of the question. Now the third part of the question. It says that a speech signal band limited to 4 kilohertz, the same question, and the peak voltage varying between plus 5 and minus 5 is sampled at the Nyquist rate. Each sample is quantized and represented by 8 bit. The number of quantization levels required to reduce the quantization noise by a factor of 4. So you have to reduce the quantization noise by factor of 4. So first of all, you should know that the quantization noise power is given by delta square by 12 in general. You can say for the sinusoidal signal also, and when the noise is uniformly distributed mainly. So NQ is, just now we saw that this is 1 upon L square, or you can also say that the quantization noise power is inversely proportional to 1 upon 2 to the power 2n. So if I increase the number of bit by 1, if suppose I increase the number of bit by 1, then it is 1 upon 2 to the power 2n plus 1, which is nothing but a approximately 1 upon 2 to the power 2n into 2 to the power 2. So 2 to the power 2 is 4. So that means on the basis of this, we can say that our new noise power is the factor reduced by the factor 4. Okay, so it is reduced by the factor 4, right? So we want that only. The quantization noise factor should be reduced by factor 4. That means we have to increase the number of bit by 1. So previously how many bits were using? 8. Now how many bits you should use? 9. So 2 to the power 9 means the number of level would be 512. Answer is option B. Correct? Now answer this question. A continuous time sinusoid of frequency 33 Hz is multiplied with the periodic direct impulse train of frequency 46. The resulting signal is passed through an ideal low pass filter with the cutoff frequency 23, then the fundamental frequency of the output. Okay, so here we will see continuous time sinusoid of frequency 33. So if we take the Fourier transform, we will get the impulse at 33 and minus 33. Correct? Okay, now here you can see we are saying that we have a sinusoidal signal. So what is the sinusoidal signal? This is the sinusoidal signal having the magnitude spectrum impulse at two frequencies like plus 33 and minus 33. I am taking the magnitude spectrum only. You may think that why we are not taking the negative, because when you take the Fourier transform of the sinusoidal signal, then you will get the minus, but I am taking the magnitude spectrum. Okay, so in this way. Now you are sampling it to the frequency of 46, right? We know that the message signal after sampling you get is fs, then the summation, and m of f minus nfs. And here the given question has the fs is equal to 46 hertz. So now when I will draw it for the 46, that means we have to shift it. So we will get, when we put n equal to 0, we will get the same. Okay, when we put n equal to 1, this will be shifted to 46. So that means plus 46, that is equal to 13. That is equal to 13. And then it will be around 46 plus 33. This is our original spectrum, 33 and minus 33. This we will get when we put n equal to 1. For n equal to 1, you will get the signal right shifted, this one. For n equal to minus 1, you will get minus 13 and 46 plus 33 with minus sign. When you put n equal to 2, when you put n equal to 2, you will get 46 into 2 plus minus 33. So it is 92 plus minus 33. So if I suppose subtract, because if we add it will be go beyond the filter cutoff frequency, but if I subtract we will get 69. So it is also going beyond the cutoff frequency. So because our low pass filter is having the cutoff frequency 23, so it will only pass the frequency which is less than 23, and we have less than 23 only one frequency which is 13. So it will pass only one frequency, fundamental frequency, that is 13 hertz. So answer would be 13. Yes. So 13 hertz we are getting. Now answer this. Yes. Good evening, Rishma. Consider the binary data transmission at a rate of 56 kbps using the baseband binary pulse amplitude modulation that is designed to have the raised cosine spectrum. The transmission bandwidth required for the roll-off factor of 0.25. The transmission bandwidth required by the PAM. 4.7. Yes, Swaraj Jadhav. Let's see. Just right after 19 seconds, I will be giving you the solution. When there is a PAM pulse required, and also I will give you the general formula. So general formula to calculate the bandwidth with raised cosine. Okay, bandwidth with raised cosine, bandwidth with raised cosine pulse is given by B is equal to RB 1 plus alpha divided by 2 log base to M. This is for M array. Uh, Get DS and AI 2024 course is there in our app. So you can download the BYJU'S exam prep app and you can check. The batch is already been started. So you can just go and visit the website of the BYJU'S exam prep. Okay, where you will get the all details. We wanted a bandwidth. Bit rate is given as 56 and 1 plus 0.25 and divided by 2 log base to m. M is here you are saying the baseband binary pulse. So because you are generating the binary pulse, so m equal to 2 because binary means you will take 0 bit and 1 bit. So to represent the 0 and 1 we need only 2 levels. So here the m is 2. So that's why it is 56 upon 2, 1.25. That means 28 into 1.25. So that will be your bandwidth. 1.25 into 28. It is 35. 35 kilohertz. Okay. So answer is 35. Okay, sir. Fees also you can check in website only Darbar. And there is a counseling number here you can see. There is a counseling number in our app as well. Uh, Let me show you if you are watching. Then it is the number is there. Okay, that you have to find it. The number is there, contact number is there. Let okay, and there you can check, see whether this is having the contact number or not. Okay, this niche in the below you can see the contact number as well, I guess. And yes, daily live. Yes, I take the live sessions now, not daily. It is for the previous year questions only. Yes, so the contact number is given. Yes, available in the description as well. And also I am running in this video. Here you can see the contact number running in the bottom bar where you can call and get the details of the course which you are looking for. Answer this question. So here in this question, it is given that an analog pulse S of t is transmitted over an additive wide Gaussian noise channel. The received signal R of t is equal to S of t plus N of t, where N of t is additive wide Gaussian noise with the power spectral density N naught by 2. The received signal is passed through a filter with the impulse response H of t. Let ES and EH denote the energies of the pulse S of t and the filter H of t when the signal to noise ratio is maximized at the output. So what is the maximum signal to noise ratio? So maximum signal to noise ratio at the output of the match filter is fixed. That is 2 into ES upon N. Okay. Now it is saying that what is ES and EH? ES and EH denote the energies of the pulse and the filter. Obviously, the signal energy for the maximum signal to noise ratio, the similarity should be there between the input signal and the filter matched, because the filter will, why we call the match filter, because the filter is having the response same as the response of the input, or if it is able to match the response of the input signal, then we will get the maximum signal to noise ratio, because there will be very much high correlation between the response of the filter and the input signal. Hence here the signal energy should be equal to the filter energy. Now, can you answer this one? Okay, so now he has gone. So let's pause it because you can see the options now clearly. Yeah. So these are the options. A binary baseband digital communication system implies the signal P of t is equal to 1 upon root Ts. T is between 0 to Ts for the transmission of bits. The graphical representation of the match filter output Yt for this signal will be. What is the output? One and a half minute left. Yes. Now in this question, as you can see that this is given that the signal which you are transmitting through the match filter is having the value 1 upon root Ts in between 0 to Ts. Okay, so in between 0 to Ts, it is having the amplitude 1 upon root Ts between 0 to Ts. This is the signal which you are giving at input. Now, because you are transmitting it through the filter, that is the match filter, what will be the output? This is the match filter we are saying. So this is x of t. This is output which we want to calculate y of t. What is the response of the match filter? H of t. So the match filter response is h of t, which is given by x of the time period, or you can say the duration of the input minus t. So the duration of the input is ts. So here it is minus ts minus t. So how will you draw the ts minus t? So when we draw the ts minus t, we will get the same pulse. We will first of all advance it and then we will fold it. So when you will just draw these h of t, then you will get 1 upon root ts. That is the same. Now, how do you get the output? Output is nothing but the input convolution with response. So you have to convolve these two pulses. So when you convolve these two, we will get a triangular segment from 0 to 2ts. What should be the slope? 1 upon ts. The 1 upon ts should be the slope, so height is 1. This is our. Okay, we also know that the output has the peak value. Output peak is equal to the energy of input. So what is the energy of input? How do you calculate? Energy of the input is minus infinity to infinity x of t mod square dt. So when you integrate it from 0 to ts, what is the value of x of t? 1 upon root ts, the whole square dt. So it is ts upon ts, it is equal to 1. So output peak is 1. So we have already got this output peak is 1. So output peak is 1 and that is nothing but equal to input energy. So in this way you can calculate. Now answer this one. This is also a good question. So last 1 minute, quickly. Consider a binary symmetric channel with the probability of error being P. To transmit a bit, say 1, we transmit a sequence of 3 ones. The receiver will interpret the received sequence to represent 1 if at least 2 bits are 1. So the probability that the transmitted bit will be received in error. That is what you need to calculate. Okay, so here we are saying that to transmit a bit, say 1, we are transmitting the 3 ones. So we are transmitting 3 ones. So when you will transmit 3 ones, what are the possible combinations that a receiver can receive? You have transmitted these 3 ones. Okay, what are the possible combination that all the bit may be received as error? Then this 001 may be the last bit is in error. Sorry, starting 2 bit is in error and last bit is received correctly. This one is the another possibility. This is another possibility. This is another possibility. This is another possibility. This is another possibility, and this is another possibility. So these are the values. Here you can see that these beats are correctly received, and we are saying that the receiver will interpret the received sequence to represent 1 if at least 2 bits are 1. Means receiver will interpret 1 here, receiver will interpret 1 here, receiver will interpret 1 here, and receiver will interpret 1 here. So these are without error received, because if you receive 011, question is saying that the receiver will receive 1 and you have transmitted 1. So when you are transmitting 1 and you are receiving 1, that means there is no error. Okay, now these are the bits where you will have an error. So this is having error, this is having error, this is having error, and this is having. These four are having error. Now, what is the probability? The probability of bit error is P. Here it is saying that the probability of bit error is P. So when you are transmitting 3 ones, all the 3 bits are in error and all are independent because you are transmitting 3 consecutive ones. So it is having the multiplication of all the probability. So transmitting 1, receiving 0, transmitting 1, receiving 0, transmitting 1, receiving 0, all are having probability P. So P into P into P, PQ plus. This is having also error. So these two are having error. So this is P square, but this is having no error. So what is the correct probability? 1 minus P plus. The third one, these two are is in error. That these two are in error, that means this is the error, and again this is not in error, so 1 minus P. And what about this? So P square and also 1 minus P, because 2 bits are in error, last 2 bits are in error. So the answer will be 3 P square 1 minus P. P cube plus 3 P square 1 minus P. P cube plus 3 P square 1 minus P. Okay, guys, so don't forget to join our crash course. The crash course we have already started for Gate 24. And if you join this crash course, then your course will be completed without any delay before the gate examination, and you may take the advantage of this. Akansha Vasist, you got answer A. Yes, answer is A. Correct. And you can join my Telegram group, and just this is the Telegram group link. This is given. Okay. So all the previous year questions of GATE, all the previous year questions of GATE we have finished from the subject communication. Okay, the GATE communication subject we have finished. Now, I think I have taken the two subjects, that is the GATE previous year questions of signals and GATE previous year question of communication from the IISc Bangalore. So if you have not watched the previous questions, today I discussed only the digital communication. If you have not watched the previous session, then just go visit and just you can see yesterday's session that was all around all about the amplitude modulation, angle modulation, and the random variable random process. Okay, Vasisht, so you want me to explain it in terms of binomial. So this is by the binomial. There are three bits required. Okay, so out of three bits, how many bits are in error? So summation I is equal to, we find that uh, 1 to m plus 1 by 2. Okay, so how many bits are in error? So at least two bits are in error. So 2 to m plus 2 by 2. So this is 4. 1 to, you will take either it will be one bit in error. Okay, there will be one bit in error or there will be no bit in error, right? So at least one bit in error. So out of three bits, if one bit in error, then there is no problem. So how many errors should be there? Minimum two bits will be in error. Okay, so two bits should be in error, then only you will get an error. So out of three bit, two bit is in error, and the probability of correct is error is p. So this is p to the power 2 and 1 minus. Okay, then all the three bits are in error. So out of three bit, all the three bits will be in error. Then it is p cube and 1 minus p to the power 0, because there is no correct data. If all the three bits are in error, then there is no bits correctly received. And out of three bit, if all the three bits are in error, then the correct probability, this is the incorrect probability, okay, error probability, and this is the correct probability. So because we are saying in the three bits, all the three bits are in error, that means incorrect probability is 3 and correct probability is 1 minus p to the power 0. So from here you will get 3p is square 1 minus p, and 3c3 is 1, and here you will get p cube. So how many bit you are transmitting, according to that you can write. Okay. So thank you for watching this session, and we will meet with more session. I am going to bring the question series. Okay, I am going to bring the question series for all of you. Question series I am bringing after 18th of September. From 18th of September onwards, I am bringing the question series based on communication and signals. Okay, that is the mixed question series, communication and signals. Okay, and the timing will be 4 p.m. Timing will be 4 p.m. Thank you for watching this. Let's meet in the next session that is going to be held on your 18th. Okay, that is going to be held on 18th of September. Advanced questions की series. Yes, this will be आकांक्षा, ये ना थोड़ा सा एडवांस रहेगा. क्वेश्चन सीरीज जो है ना, ये मिक्स्ड वाला थोड़ा सा अच्छा क्वेश्चन देंगे. ठीक है, we will take good questions only. 18th September 4 p.m. onwards, the subject will be signals and communication. Good questions of the signals and communication. Like you can say, we will take the top 10 questions. Okay, we will discuss 10 questions, but that would be good quality questions. It will be around 1 hour session. 1 hour session. ठीक है आकांक्षा, तो आप मंडे को लाइव आने की कोशिश करो. तो एक बार लाइव आओगे तो मैं ट्राई करूंगा, मतलब मुझे भी समझ में आएगा कि अगर आप लोग इंटरेस्ट ले रहे हो तो मैं ये गुड क्वालिटी क्वेश्चन जो है वो जनरेट करूंगा अपने से। नहीं तो अदरवाइज क्या होता है कि अगर आप लोग भी इंटरेस्ट नहीं लेते हो तो मोटिवेशन नहीं आता कि अगर मैं इतना मेहनत करके कोई नया क्वेश्चन ला रहा हूँ और अगर आप लोग अटेंड नहीं कर रहे हो तो फिर मजा नहीं आता है। तो ट्राई करना कि आप लोग लाइव आ सको और मंडे को एक बार लाइव मिलो और देखो क्वेश्चंस अगर आपको अच्छे लग रहे हैं तो आप बिल्कुल कमेंट करके बता भी सकते हो मुझे कि क्वेश्चंस की क्वालिटी ठीक है, तो फिर मैं वैसा कंटिन्यू करूंगा, उस लेवल के क्वेश्चंस आपको करा दूंगा। ठीक है। ठीक है, and don't forget to download the BYJU'S exam prep app. Okay, when you download the BYJU'S exam prep app, there are also the free contents available, and every day we are also taking the session at 5:30, where also I am taking the quiz session, questions of the network, control system, signals and system, digital. So those question sessions are also running in the app where you we can meet at 5:30 p.m. In the app we can meet at 5:30 and 4 p.m. YouTube. This is YouTube and this is an app. Okay. Thank you.